Welcome back, everyone. In this session, we're going to talk about contactors and relays. Now, what we can see in this image here would be the constitutive components of a contactor, or we can say the way or the basis of how they would exactly function. For example, there's this magnetic coil here. The endpoints of this coil are named as A1 and A2. Then there's a metallic core set on top of this coil. And also, as you can see, a spring is actually wrapped around this metallic core. All right? Now, the top part of the core is connected to this copper-made bar. And by the way, this bar is also called the copper contactor. Now, although we call this a magnetic coil, this would become magnetic, truly magnetic, when we connect it to a specific voltage. Now, the thing is, this voltage could be an AC one, or it could be a DC voltage. Now, when the coil becomes magnetic, it'll start pulling the core, and after that, the copper contact would be pulled down as well, and as a result of all of this, an electrical current would be created. Alright, let us move on to the next slide and continue our discussion. Let's see what we got. Okay. Here we got an image of a contactor. First thing that we can talk about would be the terminals. We have 4 of them, L1, L2, L3, and 13. And then on the side we have T1, T2, T3, and 14. And regarding the image, the terminals are set right over here. Now guys, what needs to happen is that the set of terminals that we have up here should be connected to the terminals below them through contactors. Now, in the first image, in the first version that you can see here on the left, these terminals are actually normally opened. And if we go ahead and connect the voltages, the specific voltage that we have, to A1 and A2, the terminals would start connecting. And well, it's going to go through like this. L1 terminal would be connected to T1, L2 to T2, L3 to T3, and at the end, 13 to 14. Okay, so yeah, the terminals are connected, but what now? What's the usage? Well, let's find out. Through using a contactor, guys, we can, for example, connect these terminals, L1, L2, and L3 more precisely, to a 3-phase. And for the other side, for these terminals, T1, T2, and T3, we can, for example, connect these to a 3-phase motor. Now, when the bobbins are getting activated, more specifically, the A1 and A2 terminals are getting activated through connecting a voltage to them, like 230. The terminals are getting connected. And I told you, L1 would be connected to T1, L2 to T2, and L3 to T3. And this would start up the motor. Okay, now let me move on to the next slide. All right. Pay attention, guys. The contacts that we have in between these terminals, the contacts that would connect L1, L2, and L3 to T1, T2, and T3 more precisely, these contacts are what we actually call the power contacts. But we have another contact, a contact that would connect terminal 13 to terminal 14. Now, this one is a contact that we actually call an auxiliary contact. Now, just know that these contacts are mostly used in control circuits. And, well, if you don't know what they are, or if you don't know what I'm talking about, don't worry, because later on we're going to talk about them in more detail. For now, let's just stick to our own discussion. Now, guys, sometimes when we look at our system, in between the contactors that we have, we might find a normally closed one, like the one that you can see here in the image. Now, they would usually be specified by numbers such as 21 or 22, exactly like what we have here. And, well, you know what, guys? Just be aware of this. Yeah, that would be enough for now, because later on we're going to talk about all of these more completely when we reach control circuits. Alright, guys, let me give you a point regarding contactors in power circuits. Basically, we have two types of contactors. A normally open one, and you can see its symbol is schematics. Here, this would be the IEC symbol, and the NEMA, or the American symbol. And we also have a normally closed contact, as in the second type, obviously. Now again, we have the IEC symbol and also the NEMA symbol. Okay, let's move on to the next slide. Okay, here we can see two symbols for the contactors, IEC and NEMA, obviously. Then this would be the bobbin of the contactor, and it is usually specified with K1M, K2M, K3M, and so on. Now we have two terminals set on both sides of the bobbin, specified by A1 and A2, as you can see. One side would be connected to phase, the other one to null. And for specifying the other terminals, we actually use numbers like 1, 2, 3, 4, 5, and 6. If we are working based on IEC standards, remember that. And well, these are actually the terminals that we saw before. The L terminals and T terminals. Now, let's talk about the symbol that we have when we are working based on NEMA standards. For specifying the bobbin, first off, we would use, for example, M1, M2, M3, and so on. And normally open contacts are specified like this. Most specifically, the power contacts. Right, moving on again. Now, guys, if you remember, we said that we might have auxiliary contacts in our system as well. Now, if this was the case, this is how we would display them. Again, we have the power contacts right here. And these would be the auxiliary contacts, which, as I mentioned a few minutes ago, we would usually find them in control circuits. Now, just like what we did in our previous session, let's watch a clip to understand everything better. In the video, we'll get a close-up view on the contactor. Like, for example, we got the terminals here, the L terminals, and then on the other side, we have the T terminals. Okay, then we have the bobbin terminals, more precisely A1 and A2. We also have the auxiliary contacts, terminals 13 and 14. And, well, as well as 21 and 22. And by the way, guys, we are able to activate this contactor quite manually, and it would be completely like this quite easily. And yeah, that would be all, guys. That would be all for the concept of contactors.